Hello. Let's try to work on graphing our quadratics using the vertex form. So the first thing we need to do is we need to get the parent function. So the parent function is going to be f of x equals x squared, and that's the function we're going to use to define everything else. So to graph it, its vertex is at the origin, and then the pattern that we have to follow is up 1, right 1, up 3, 1, 2, 3, right 1, and up 5, 1, 2, 3, 4, 5, and right 1. Alright, and that pattern works on the other side as well. And it's really important to remember that pattern because that's the key. So we've got up 1, we've got up 3, and then we've got up 5. After that, everything just builds from there. And so here's the rules. And actually, when you're graphing, I'd like to think of those two rules switched around. So we find this new vertex at hk, and then look and see if the number in front, or a, is negative, and then after that use that factor a if it's not 1, and scale the pattern, the 1, 3, 5 pattern that I just showed. So let's go ahead and graph these things and see what happens. Alright, so the first thing I do is get the vertex. Now remember, we talked about in class how because in the formula, and let me back up for a second, because in the formula it's minus h, the sign on h will always be the opposite. So if I look here and I see plus 3, the vertex will be at negative 3, negative 4. So first thing, graph the vertex. Next thing, figure out whether this opens up or down, and we do that by looking at the sign in front. There's no negative, so it will open up. And then since a is 1, we don't see the 1 written there, but there's no number there, so that's how we know. Then just follow the 1, 3, 5 pattern to graph it. So up 1, right 1. Whoops, sorry about that. Up 3, right 1. And then up 5. Right 1, and do the same thing on the other side. And then we fill in the parabola. By the way, the other things that were asked for besides the vertex was 1, the axis of symmetry. The axis of symmetry is just the line that goes through the vertex and cuts the parabola in half. And since it's a vertical line, it's always x equals. So we're going to get x equals negative 3. A minimum or a maximum, and so this has a minimum, my lowest point. So, and the minimum value, it's not the coordinate, it's just the y value. So the minimum value is negative 4. And the last thing was domain and range. So domain for any parabola, domain is basically all real numbers. But the range, there's always a starting point, and sometimes it goes up and sometimes it goes down. But this, we're going to start at negative 4, and then it goes up forever to infinity. Alright, for the rest of them I'll just graph them. So for this one again, let's go through the same steps. Vertex, positive 7, positive 10. Second, sign. It opens down. Third, is there a number? No, so a is 1, so then I just use my pattern. So down 1 over 1, down 3 over 1, and down 5 over 1, and follow the same pattern on the other side. And then I can fill in the parabola. Alright, we get to something a little different here. So vertex at negative 7, 8. It's going down because of negative, but here for the first time we have a number other than 1 up front. So how does that affect us? Well, we go back to thinking about our pattern. Our pattern was normally 1, 3, 5. So now what we're going to do is we're going to multiply it by that constant of 3. So then our new pattern is going to be 3, 9, 15. And we're going to graph the same way using the new pattern. So it opens down. So instead of 1, 3, 5, we're going to go down 1, 2, 3, and over 1. Then down 1, 2, 3, 4, 5, 6, 7, 8, 9, and over 1. And we certainly cannot go down 15. So we'll stop there. And notice how much, I guess, thinner the parabola is, or how much it looks like, parabola, how much it looks like it's stretched out. So there's where we get the name vertical stretch. For this one, if you need to fill it in, I know it looked empty, so the vertex here is going to be at negative 5, 0, and up front we have a positive 1, so we're not going to get any effect to our pattern there, so I just have to find negative 5, 0. It's opening up, and so then I just use my pattern. 1, 3, 5. Do the same thing on the other side. Alright, here's a little different twist on it. So now the 0 is on the inside, so that means we're not moving left or right, just up or down. So the vertex is going to be at 0, negative 3. But again, nothing in front, so our 1, 3, 5 pattern remains the same. So 1, 3, 5, 1, 3, 5, and draw in the parabola. This one's the same exact one as the one right above it. I don't know how that happened, but we'll just cross this out. And let's move to the next one. Alright, so here, notice there's no horizontal or vertical change. Alright, so I could write this if I wanted as 2/3 x plus 0 squared plus 0. So the vertex is going to be at 0, 0. It's positive, so we're going to open up, but now we have a new factor. We have that factor of 2/3. So just let's go back to our 1, 3, 5 pattern, but now I have to multiply by 2/3. So it's 1 times 2/3 is 2/3, 3 times 2/3 is 2, and 5 times 2/3 is 10/3. Don't worry about the fraction. You've got a calculator. Let it handle it if you need it. So now instead of up 1, up 3, up 5, we're going to go up 2/3. Gotta just kind of estimate it. And then from there up 2. And then lastly up 10/3, which would be 3 1/3. And then try to do the same thing again. And see, because this is a fraction, the parabola is a little wider than it was before. And then lastly, on the graphing end, we have a vertex that we don't have to worry about. Like it's not hidden. So the vertex is at 5, 3. But again, we have something up front. The negative sign means it's going to go down, and our pattern's going to be messed with again. Alright, we're going to multiply it this time by 2. So 2 times 1 is 2, 2 times 3 is 6. 2 times 5 is 10. So instead of 1, 3, 5, we go 2, 6, 10. And we're going down because of the negative sign. So 2, then 1, 2, 3, 4, 5, 6. And we're not going to be able to go 10, so just do our 2, 6 on this side as well. And there we go. Again, noticeably thinner than the first one. I'll do a separate video for the writing the equations.